El Niño, a climate phenomenon that affects the weather patterns of the world, especially in the tropical and subtropical regions. In this video, we will explain what El Niño is, how it forms, what are its impacts, and what are the predictions for the future. El Niño is a Spanish word that means the boy or the child. It refers to the Christ child, because the phenomenon was first noticed by fishermen off the coast of Peru around Christmas time. El Niño is part of a larger cycle called the El Nino Southern Oscillation, which also includes La Nina, the opposite phase of El Niño. El Nino Southern Oscillation is a natural variation of the ocean and atmosphere over the Pacific Ocean that affects the global climate. It involves changes in the sea surface temperature, the atmospheric pressure, and the wind patterns over the Pacific Basin. The sea surface temperature is the average temperature of the top layer of the ocean, about 1 meter deep. Under normal conditions, the trade winds blow from east to west across the tropical Pacific, pushing warm water toward Indonesia and Australia. This creates a temperature difference between the western and eastern Pacific, with warmer water in the west and cooler water in the east. The cooler water in the east is replaced by deeper water that rises to the surface, a process called upwelling. Upwelling brings nutrients to the surface, supporting marine life and fisheries. The temperature difference also creates a pressure difference, with higher pressure in the east and lower pressure in the west. This pressure difference drives the trade winds, creating a feedback loop that maintains the normal conditions. However, every few years, this feedback loop breaks down and El Niño develops. During El Niño, the trade winds weaken or reverse, allowing warm water to spread eastward across the Pacific. This reduces or stops the upwelling of cold water in the east, making the sea surface temperature warmer than usual. The warmer water also affects the atmospheric pressure, creating lower pressure in the east and higher pressure in the west. This further weakens or reverses the trade winds, reinforcing El Niño. El Niño usually lasts for 9 to 12 months, but can last up to 2 years. It typically peaks around December to February, but can vary depending on the strength and timing of El Niño. El Niño events occur irregularly, with an average frequency of once every 3 to 7 years. The strength of El Niño also varies, ranging from weak to strong. The strongest El Niño on record occurred in 1997 to 1998, when the sea surface temperature anomaly, the difference from normal, reached 4 degrees Celsius in some parts of the Pacific. El Niño has significant impacts on the weather and climate around the world, especially in regions that are influenced by the tropical and subtropical regions. El Niño alters the normal patterns of rainfall, temperature, and wind, causing droughts, floods, heat waves, cold snaps, storms, and wildfires in different parts of the world. El Niño also affects the ocean currents, the marine ecosystems, the agriculture, the health, and the economy of many countries. Some of the common impacts of El Niño are: in South America, El Niño brings heavy rains to the normally dry coastal regions of Peru and Ecuador, causing floods, landslides, crop failures, diseases, and infrastructure damage. On the other hand, El Niño reduces rainfall in the interior regions of Brazil, Colombia, Venezuela, and Bolivia, causing droughts, water shortages, forest fires, and crop losses. In North America, El Niño tends to bring warmer and wetter winters to the southern and eastern parts of the United States and Canada, increasing the risk of floods, mudslides, storms, and tornadoes. On the other hand, El Niño tends to bring drier and colder winters to the northern and western parts of the United States and Canada, reducing the snowpack and increasing the risk of droughts and wildfires. In Africa, El Niño affects the timing and intensity of the rainy seasons in different regions. El Niño usually brings more rain to the eastern and southern parts of Africa, especially in Ethiopia, Kenya, Tanzania, Malawi, Mozambique, and South Africa. This can lead to floods, landslides, crop surpluses, disease outbreaks, and humanitarian crises. On the other hand, El Niño usually brings less rain to the western and central parts of Africa, especially in Senegal, Mali, Niger, Chad, Sudan, and Somalia. This can lead to droughts, crop failures, food insecurity, malnutrition, conflicts, and displacement. In Asia, El Niño affects the monsoon seasons that bring rain to many countries. El Niño usually weakens the summer monsoon in South Asia, especially in India, Pakistan, Bangladesh, and Sri Lanka. This can lead to droughts, heat waves, water scarcity, crop losses, power shortages, and economic slowdown. On the other hand, El Niño usually strengthens the winter monsoon in Southeast Asia, especially in Indonesia, Malaysia, Philippines, Thailand, and Vietnam. This can lead to floods, landslides, crop damage, disease spread, and infrastructure disruption. In Australia and Oceania, El Niño usually brings drier and hotter conditions to most of the continent and the surrounding islands. This can lead to droughts, bushfires, water restrictions, coral bleaching, and reduced agricultural output. However, some parts of Australia and New Zealand may experience wetter and cooler conditions due to changes in the jet stream and storm tracks. These are some of the general impacts of El Niño, but they may vary depending on the strength, timing, and location of El Niño. El Niño also interacts with other climate factors, such as the Indian Ocean Dipole, IOD, the Madden-Julian Oscillation, MJO, and the Arctic Oscillation, AO, which can modify or amplify its effects. The prediction of El Niño is a challenging task that involves monitoring and modeling the ocean and atmosphere over the Pacific and beyond. Scientists use various indicators, such as the SEA Surface Temperature Anomaly, the Southern Oscillation Index, SOI, and the Multivariate ENSO Index, MEI, to measure the state of ENSO. They also use various methods, such as statistical models, dynamical models, and ensemble forecasts, to project the future evolution of ENSO. According to the latest ENSO outlook from the World Meteorological Organization, WMO, there is a 60% chance of El Niño developing in 2024. The WMO also warns that El Niño could be stronger than usual due to the influence of global warming. Global warming increases the average temperature of the ocean and atmosphere, making it easier for El Niño to form and persist. Global warming also alters the background climate conditions, making it harder to predict the impacts of El Niño. Therefore, it is important to be prepared for the potential consequences of El Niño in 2024. The WMO advises governments and stakeholders to monitor the ENSO situation closely and to implement adaptation and mitigation measures to reduce the risks and vulnerabilities associated with El Niño. The WMO also encourages international cooperation and coordination to share information and resources to cope with El Niño. Thank you for watching this video about El Niño. We hope you learned something new and interesting. If you have any questions or comments, please leave them below. And don't forget to subscribe to our channel for more videos like this one. See you next time.